And welcome back. Now today I've got two PCBs to show you. Yes, this one here and this one here. What do you mean they look the same? Well, alright, they are sort of the same, but there's a reason for me designing them in the way that I did do. Now they've been provided to me by JLCPCB, hence the key ring stroke nail clipper stroke bottle opener. Keyring on here, nice little thing that came with it. But there's a serious side to all this. Now this circuit that's on this PCB was from video 173. That's the 80 tiny on-off kill process. Okay, and I'll show you it all working in a minute. But there's an underlying reason for me creating this in the manner that I have done. If you recall back in video 173, I said, I'm thinking about putting this on a PCB, and I had lots of suggestions about what to include, what not to include, how to make it easier and so forth. And I listened to them all, believe me, but then I thought, okay, let's just take a step back a minute. Who is this channel for? Oh, yeah, you guys, that's right, you guys. But hopefully, lots of beginners are coming along the way. Not absolute total beginners are going to be doing this, but people who have had a bit of playing about, they want to take that next step, okay? Because this PCB, let's get you a blank one to have a look at, this one here. Now this is a dual purpose PCB. You can put on here either SMD components or through hole. Yes, it's a dual purpose one. That's how I've designed it. Thank you. Yes, so dual purpose PCB. Because what I want is for you guys out there who are a little bit wary of SMD soldering to think, do you know what, I might have a go at that. Yes, that's what I want, because let's face it, a year ago I knew nothing about PCBs, but I took it upon myself to think, right, now's the time to learn. And you saw some of my less than perfect results along the way. Yeah. All right, but they got better, didn't they? And now I feel pretty comfortable in making these dual-sided PCBs. In fact, I even made a 4-layer one once, didn't I? That was pretty nifty as well. Anyway, the point is I'm making this one so that all those people who think, I don't think I can solder SMD, well, there's good news for you. One, all the components, no, some of the components, a lot of the components on here are huge. That is to say, for SMD stuff, relatively speaking. So I've chosen 1206 components. So if you look at this resistor here, for example, that is a huge space to put a service mount resistor, but it is in fact a 1206. Let's look at that in real life and you'll see what I mean. So there's the actual soldered one here, and that is big. I mean, it's not like a speck of dirt like some of the stuff I've soldered on there. If you go down to 0603, that's about the minimum most people would want to do. I have soldered 0402 when my eyes were good, by the way. Yes, not now, no. And it was, all right, a bit of a challenge. But 1206, I mean, you know, if you can solder, then you'll be able to solder something like that. No trouble at all. And even better news, if you think, I don't think I can solder that tiny little MOSFET here, or that one there, well, skip that one and just solder the through hole component instead that goes next to it. Okay, there's always an alternative to solder on. So this 100k resistor, you notice there's a hole at the top there, hole at the bottom. That's for the surface mount. That's for the through hole component. Okay, so you can put either or on, not both. Do not put both components on. I don't know what would happen if you did that. Probably not work. So anyway, that's what this is for, and I explained to JLPCB that's what I want to do. I want to get more people, well, both involved in SMD soldering who think perhaps, no, I don't want to do that and I've never done it. Okay, and secondly, to make people think, do you know, I could develop a PCB like this for large components and I won't feel quite so wary of doing it. So let's just talk a little bit more about that going forward. And if you notice this one that I showed you last week, this little dual thing that runs on a 13 layer on 85 and probably other 8-pin AVR chips as well. That's another thing that you probably feel quite confident in soldering because it's all through hole, apart from the one capacitor underneath. If you look, there's one little tiny, that's an 0603, for example, that one under there. See if I can get the light on it. That little 100 nanoF, that's a 0603. And yeah, all right, it's small, but you know, there are some tools though that you absolutely need. Don't think you can just solder all this stuff with your dad's old soldering iron that you put into a furnace or something, because it's just not going to work. I've just bashed the camera now, so I don't know where I've got up to. I'm going to go through some of the basic tools you need for SMD soldering, just to make life easier and more to the point, to increase the likelihood of success. Okay, now it's not rocket science. If I can do it, you can do it. It's as simple as that. And as I say, with this particular board, if you get stuck, you can just think, that's too much for me. I've tried soldering this little tiny thing on in. I can't do it. I'll put the through hole component in instead. Now, as you can see, this is made as an Arduino Shield, and I've got it plugged into an Arduino here, this one. If you look at this one here, you'll probably see all the pins. Now, I've only soldered some of the pins in because some we're not using at all. Right, let's fire this up so you can see it working. We'll swap them over just to show that they both work. Then I've got some slightly less good news on the power supply front at the top here, but one step at a time. Right, let's clear the decks and start wiring things up. Right, it's all wired up. Well, this one is plugged in anyway. Now you can see that I'm using a USB socket here to power it. And that's the first bit of bad news, all right? The USB socket is, of course, only surface mount. And soldering those little tiny pins inside there, it's only the outer two that we're using, so the plus VE and the ground. In fact, they call it USB VCC, I think, and ground, plus the little lugs on each side. It's easy enough to do, but you do have to have a fairly fine soldering iron to get in there, but it's doable. So I've given you an alternative, this thing here. Now this is surface mount as well, but as you can see, it's only got 4 big fat lugs on the sides. That's easy to do. Even the voltage regulator here, that's pretty big and chunky, no problem at all. I wouldn't have thought anybody can do that. If you can do soldering, you know, through hole soldering, that would be just as easy. SMD. The two capacitors are 0603, I believe so. They do look quite large though there, but they're easy enough to do as well, in my view. So if you do want to connect up your power supply like this via a jack, that will take anything up to 16 volts, as it says on the PCB there. That's probably the easiest way to power it up. Or you put in your 3-pin header here, plus 5 volt ground and not connected. I've done it this way so that if you were to flip the plug over the wrong way round, it would be plus 5 volts here, ground there, nothing had happened, but at least you wouldn't blow things up. That's why it's always a good idea to have a 3-pin rather than a 2-pin power connector. I want to give a shout out to my sponsor JLCPCB, manufacturers of custom PCBs, made simple. One of their new features that's coming up shortly is their SMT Assembly process. And their webpage contains a lot of information about what their capabilities are and some various very common facts. If you prepare your PCB using Easy EDA, you'll find that when you place components, you have the option of using their LCSC assembled catalogue. As you can see here, I've just chosen the IC that I'm going to be using in a future project, and it's come up as part of the LCSC assembled list. That means they can pick and place it for you on that board. If you can, try and use their basic list rather than the extended list, which means they'd have to change the components in the pick and place machine. Designing a board could not be easier using Easy EDA, and the fact it links into the JLCPCB website is going to make ordering an assembled SMT PCB an absolute breeze. Why don't you try them out today? And as I say, everything else is all, you know, dual SMD stroke through hole. So let's fire this up just so that you remember. Quick summary then. I know you're all desperate to go off and watch video 173 if you missed it, but just to tell you what this shield does then, you have your Arduino, you're ready to turn it on, and let's face it, the only way you'd normally turn it on is by the power switch, okay? And the only way to turn it off again is via the power switch. Yeah, well, that's not always that convenient, is it? So what this does, it allows you to turn on the underlying Arduino, the one you plugged it into, via this little switch. And this switch, incidentally, is brought out not only to a through-hole switch and a surface mount switch, but see those 2 pins there? That's for an external switch, so you can plug that into, you know, to a standard switch on a project case or something. So you press that once, it all powers up, the underlying Arduino fires up and it latches on. Great. When you want to turn it off, you press the switch again, the LED on there starts flashing to say I'm in shutdown mode, or at least I've asked the Arduino now to shut down. I'll just sit here until it says OK. And when your Arduino, the one underneath now, remember, says OK, I'm done, I've closed any files that might be open, I've written away some logs, I've sent an email, whatever your Arduino needs to do, if anything at all, it will send back a response to the Shield to say, OK, you're clear to shut down the power now, at which point this does. Simple as that. Okay, nice and easy. And the LED on here, which you'll see in a sec, is controlled by this jumper here. If you take that off, the LED dies. If you want an external LED, you disconnect it to the top pin on there. All that is explained in a document that I'll put up into my GitHub. So let's turn it on. Right, that's it. It's on. And when you hear the beeping sound, that's the Arduino underneath that one saying I'm running. All that Arduino is in fact doing is beeping, nothing else. Which emulates, you know, the Arduino actually doing some real work. You wouldn't want it beeping like that normally. And I've just put this beeper in here into a couple of ports that I'm using just to test it out. So when you come to switch it off, you press it again. And it's dead. Now, I don't know if you heard those little beeps there from the Arduino, because I'm trying to keep the noise down with this thing. We'll try it once more. Right, so it's on. Now, in my code, I've said you can't switch it off for 5 seconds. That's to stop you accidentally pressing it again. So it'll be on, off, you know. So we'll press it again, and this time you'll hear 5 beeps or something like that from the underlying Arduino before it switches off. That's it. Right, that's all there is to it. Right, very simple. And the beeps, by the way, are from the underlying Arduino code. You don't have to do that. That's just an indication that the Arduino is responding. If I hit my camera once more this show, I should be very annoyed with myself. Right, okay, that's the surface mount version. And these yellow things you see here, these are jumpers. You wouldn't normally necessarily use big jumpers like that, but they are easy to get off. You just pull them off and they come off and stay off. And putting them on is just as easy. Normally what you'd actually use is, I've got the two sorts here. One's that yellow one you just saw, and the other one is that little tiny black one. But I find these black ones quite awkward to get off. And they're very easy to lose. I should imagine my workshop floor is littered with things like that. So that's that one. Let me stick on the through-hole version, and you'll see how differently that operates. Right, so that's plugged in. Let me just plug in my little test beeper in here. I've used a couple of the analog ports. Well, I say analog ports. It's the wrong thing to call them. They're analog capable ports, but they're basically just GPIO pins that are analog capable, but we call them analog, and then people tend not to use them GPIO, so beware of that. Okay, let me just put this in. Okay, that's in. It's just going basically through this shield and being plugged into the underlying Arduino, so that's all in. Let's fire it up. There it is. Oh, it's a little bit quiet. Let me take that. I'm just going to take that sticker off. Don't blame me. Oh, that is loud. Right, so that's the Arduino talking to this shield again, saying I'm running. Okay, so let's press the button again. And off. That's it. Simple as that. So you've got a functional shield. It actually does something, all right, which you may find useful and be able to switch your Arduino off like that. But as I say, the main purpose of creating it in this manner, twofold. One, so that you can create either this version, or mix and match, which I think I did mix and match one component on here. I can't remember which one it was now. No, I can't remember which one it was. And as I say, the power stuff is all SMD, but big and chunky and easy to solder. And a lot of it on this board is optional. If I show you a blank board. Now, the key on here, if you look down the bottom there, you see that bit? It says star, optional, and arrow, or triangle, equals through hole. Now, there's lots and lots of optional stuff on here. So there's all this stuff here that's got a star on it. You see that? You don't put that in unless you want to. You can refer to the circuit diagram to find out why it's optional. But the one thing I've done here is to put basically the minimum amount on to make it work. So I've not put stuff on that you don't need. So I haven't put the pin and headers at the top or bottom or all these through-hole switches. I did one of them I put a double on. No? Oh, that one. There's the through-hole switch rather than the surface mount. You see that? So it's all pretty straightforward, even though the PCB itself looks a little bit busy because it's got twice as many components on it as you're actually going to fit. Right, now I do have a bit of an announcement to make regarding how I'm going to get these sample boards plus the components that were supplied by LCSC to anyone who's interested, because the last time I did this there was a bit of a hiccup, so we'll talk about that in just a minute. Right, so sending out PCB samples, and in this case all the components that go along with it. Now the last time I did it, it cost me in the region, just for the postage, between 60 and 70 British pounds, all right, as a final cost to me. That didn't include the jiffy bag. They were just talking the stamps to go on the envelopes. Okay. Now that was quite a lot, and more to the point, quite unexpected, and that sort of wiped out my earnings for the entire month on that video. So I'm having to rethink how I'm going to do this. Now I was shocked as anybody else at the cost of sending stuff to anywhere other than the UK. To the States it costs me £3.45. Yeah, there's the price on screen. To Australia it cost me £3.60. To Europe it cost me £2.70, and to the UK it's about 80 pence or 85, something of that region, about £1 including the jiffy bag. So what I'm going to have to do from now on is request that if you want one of these PCBs and you email me in the usual manner, you go to my About tab on the channel and go, yes please, I'd like one of those boards and all the components. I'll say fine, go to my blog page where you can click the PayPal button, send me the value of wherever it is you live in the world, and once that's done I'll send you the stuff, so that basically I'm not out of pocket. Whilst I don't mind subsidizing the jiffy bags and the effort of doing it all, that's fine, but the postage really was a bit of a killer last time, to be quite honest. Although I do hope that the people who got the boards A, made use of them, and B, found them useful. So yeah, so here is an example. This isn't live yet, so if you try and go onto this page and you get a 404, it means I haven't done it yet. Okay, but this is a mock-up of it all. Right, so this is the page that will eventually be live. It's not live yet, which is why it says private at the top. It means nobody can see it. But basically I've got 3 entries on here. For UK recipients I'm saying £1. For European recipients I'm saying €3.50, and for everywhere else $5. Now the $5 is a little bit low even for the States, and certainly for Australia and Thailand and places like that, but let's just keep it simple. I don't want to have 20 different postage rates here. And what that does basically is pay for the stamps that I've got to put on the envelope, and perhaps it might even pay for half the jiffy bag or something. But for that you get, though, the PCB. And in this case, the components, so that you can start building and playing with it and having a bit of fun, because that's what it's all about, isn't it? Okay. Now, if you think, nah, this is rubbish, I hate this, I don't want to do it, I don't want to pay nothing, well, okay, then we'll have to not do this whole thing about sending out PCBs. Now, at the moment, I've got 10, all right, 10, count them. Okay, I've got more than that, but I'm only going to do 10 initially, just to see how this works and see if I get anybody to actually want them and pay the money for this. UK recipients, of course, are getting a great deal. Even European recipients, really. But say, for example, instead of talking about this particular board now and the components, say we were talking about this one here, which I have had some inquiries about. People saying, oh, can I have one of those little boards? Would you be prepared to spend that sort of money on a little board like this? I mean, from my point of view, the postage is the same. I can go up to 20 grams, you see, with that postage cost. But as I say, I'm a little bit uneasy about doing it, but I've got to do something. I can't afford that sort of outlay whenever I've got a PCB to give away. So appreciate your comments. And if I think, yeah, it's okay, that page that you just saw, the payments page, will go live. And there's instructions down the bottom. Please, please, please read these. Otherwise, you're not going to get it. Because what I'm saying there, basically, if your name is Sam Smith, no relation to the singer, but you're Arduino, your YouTube name is Big Billy Mates or something, and I suddenly get a payment from Sam Smith, I'm not going to know how to tie that up. I need an email from you when I've said yes, there is a board available, with your name, address, the country. Please tell me the country you live in. So many people didn't do that last time. Then I can tie things up and send them out. Okay, so we'll just see how this goes. I dread to think how commercial premises actually do this sort of thing day in, day out. I guess their setup must be a lot slicker. So orders come in, you pay, and the address and all that gets done automatically. Now you have to pay via PayPal, but that doesn't mean you have to have a PayPal account. Okay, you can pay by credit card or debit card or whatever PayPal takes, and it will just come into my account with, of course, a certain fee taken off. So don't think I'll get every penny that's on this page, because I don't. Okay, so PayPal takes their little bit, but at least I'll know that there's something in the kitty there to pay for future stamps and things. So, okay, that's that bit. Now, the other thing to remember is Chinese New Year's coming up pretty soon. I'm recording this around about the, what's the date today? I can't read that, it's too close. 13th of January, I'm recording this one. Chinese New Year is supposed to be around about the 27th to the 4th of January to the 4th of Feb, around that period. But Chinese factories tend to take a nice big chunky holiday at that time, and certainly office people and things. LCSC are still going to be around for components should you need any extra ones. And I put an order in with my own money a couple of days back, so I'm waiting for those to come in. Get there ahead of the time, you know. JLCPCB will be closing down, I believe. You need to go onto their webpage and just have a look to see what the rules are. I think what they say is you can submit stuff and it just sits there until they come back on about the end of January, and then they'll trundle them all off. But you can imagine there'll be a little bit more of a delay. But that will apply to all of China. You go onto eBay, you go onto Banggood, AliExpress, they'll all be saying, we're out of here. We got holiday, and they will take it. So that was the first thing. I'm sure there was something else I was going to talk to you about as well. Yes, the second thing is, if you decide, yeah, I'd quite like one of those boards and components and I'll have a go at doing it. First of all, I'm not providing any kind of technical support with this. As you've seen, I have two samples of the board that I created myself, built myself, with my dodgy eye. So you can imagine how long that took, trying to line things up and get the soldering on the right place without burning myself. Fail. Big fail. I burnt my finger somewhere. You probably can't see it anymore. So I've got both things all wired up, and that's why I've got the power supply one on here, just to make sure that all worked as well. As I say, there's one little tiny error with the through hole component for that diode, but that's all documented on the bit of paper that comes with the PCB and components. Yeah, I think that was what I was going to talk to you about. Oh, as an added bonus then, if you did want one of these little tiny 85/13 boards to plug into your PCB, no components for that one. I'll put one of those in the packet as well if you remind me to do it. Okay, because I've got a few of those to come, and you can have, I hope I've got 10 of those. Well, you'll soon find out. But I found these extremely useful because of the ICSP connector here. Okay, I think that's probably covered most of the things of this particular video. As I say, I'd like to get these in the hands of people who really do want to use them. The components that you're going to need as a minimum to get this working, you're obviously going to need a soldering iron, you know, a reasonable soldering iron, but any like that. Remember that Antex one I used to have, the old Antex, Type C I think it was called. That's perfectly good enough for both surface mount and through hole. That will do you. You'll do yourself a big favour by getting yourself a tube of flux. This one here, which you can't see when I hold it up to the camera like that, this one here I got from Banggood, and it's pretty good. It says no clean. Do not believe that for an instant. You do need to clean it off, and for that I use isopropyl alcohol, which you can buy in big bottles from places like Amazon. You want to see that? Hang on a second. Here we are, big bottle of isopropyl alcohol. Right, yeah, that says caution on there, so I don't drink it. Now that's not particularly cheap, that bottle, because I got the biggest bottle I could find really. That was about £12, I believe. But you use it very sparingly, right, to clean those boards off with them. You can use a toothbrush. All what I've got is a horsehair brush that, you know, is nice. You've seen that in a previous video. But anything like that, just to get into those components between the leads, just get rid of all that flux. And the other thing I can so strongly recommend is this set of tweezers. Now, I actually bought this from Banggood, but I'm sure others are around. And funnily enough, I tend to use that one the most, the curved one. I'm sure it says in the description ESD protected, but I don't see how metal tweezers can be electrostatically protected anyway. But anyway, they're ideal for picking up SMD components and putting them onto boards while you solder them. I'm assuming you're not using a hot air gun, for example, and solder paste, because that means, well, you're already an experienced SMD constructor, aren't you? So you can hold very, very tiny components with this. These are very good quality. They'll go down to tiny. I mean, I've held 0402 components with this. So yes, it will definitely work. And this complete kit, there's a lot of tweezers in there. Sometimes you need two. So that a bit like a doctor on a operating table, you know, scalpel, swab, yeah, you need two sets of tweezers. What else can I recommend you get? Some decent leaded solder. Do not ever try to solder with unleaded solder. It's just absolutely impossible for hobbyists. That's why they let us hobbyists use leaded stuff. Okay, so you do need that. And what you will need is a multimeter, because without a multimeter you will not be able to identify the components properly. So because obviously they come to me in big long reels. Let me show you. So this is a typical strip of components. This is a 100k resistor from LCSC, as I say. Right, so they're like this on a big long strip. This is what they feed into their pick and place machines. Of course, it's not a little tiny strip like this. You know, it probably contains 1,000 or more. But you can see these are fairly chunky for SMD components, and they do look bigger than what you might think they do once you've placed them onto the circuit board. And the way I did it for the surface mount stuff, because I deliberately didn't want to use my hot air gun or anything like that, that would effectively cheating. When I soldered the surface mount stuff, what I did was place some flux on the correct place. So let's take that resistor again there, right? So what I did was get the flux, put a splodge of flux on. Then you can never ever use too much flux, so don't be worried about putting too much on. Splodge of flux. Use the tweezers to place the resistor in place and just pat it down. Remember, the flux is sticky, so hold it in place for a bit, and then you can hold the component in place with the tweezers on top while you apply the soldering iron to one end, and that solder will take in about, you know, a quarter of a second, and it's done without the sound effect, obviously. And then just do it from the other side as well. It's easier than you think. And if you want to practice board first, which I can only recommend, it's how I started, a little practice board from Banggood, I bought it. They supply, with the practice board, some random SMD components, including some chips, would you believe? And you can practice on that and you'll get the hang of it very, very quickly. And then you can perhaps build this rather than use this as some kind of test board, because you might be frustrated and decide not to do that. The other thing I have is a special holder for PCBs, and it's worth its weight in gold, but only if you're making enough PCBs to make it worthwhile, of course. It looks a bit like this. Right, I've had to zoom right back because this is a thing that sits on your workbench, holds it at a nice height, and clamps this in. So this is all spring loaded here. You can see there's a spring on the right hand side, and it's got a little slot in this black thing just for putting your PCBs in. There we are, like that. And then you can solder stuff on the top, or if you're doing through hole stuff, put it through, flip it, make sure it doesn't fall out, of course, and solder it underneath. All very good. It's got various adjustable bits on here to stop the legs falling apart and this twisting. So if you want to make it hard to move this, which you do for SMD stuff, then you need to turn these up tight. Otherwise you can loosen these off and it will spin quite freely. Right, so that's I don't know where I got this from. It wasn't from Banggood though. It was probably a UK supplier. I don't know where. If I find out where I got it from, I shall put a link in my GitHub and in the video description down below. Right, I think we're done here today. Okay, there's a lot to take in, I think, today for you guys who really would like to experiment with this, and indeed to make that shield and have it actually do something to your Arduino. Okay, so please let me know if you want to do that. Send me an email I'll put a link into my GitHub and into the description below where my email can be found on the About tab in my channel, but I'll put a link down there. As you can hear, this is bleeping away, so it's working quite nicely. And don't forget that you've got an ICSP header pins here for connecting your cable to your programmer. Otherwise, you won't be able to program a surface mount device, as I found out to my cost. Let's just shut that down. So when you've soldered on an AT-Tiny85 in there, when you connect it all up and you press the button, nothing happens, of course. You go, oh, what have I done wrong now? And you check all the voltages and going through with your multimeter, which is why it's useful to have a multimeter. And then, of course, it dawns on you that nothing's happening because there's no actual code or bootloader or anything in that AT-Tiny85. So you do need this to plug into that and program it, unless you've pre-programmed it, of course. And the sketch and all that can be found in the GitHub for video 173. I'll probably put a link in again for this one just so you can find it. Okay, that's it. I think we're done here. Please, comments down below. If you don't think this is a good idea, then we'll just scrap the whole thing. But if you think, yeah, I wouldn't mind having a go, and after all, I think it's value for money. You're getting 2 PCBs, including that little one, plus the components, for a fairly nominal sum. And that's just the way life is for the postage, I'm afraid. UK postage rates or worldwide postage rates. I don't know who determines these, but that's the way it is. And yeah, I hope you're sympathetic to my needs in this case. All right, I think we're done then. Thanks very much for watching. Look forward to hearing from your comments. See you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.